Hello everyone. Today we're gonna come back to the class and might be the last one that we're talking about the trees itself. I would like to say I want to skip the spanning tree into kind of additional materials of the course that I will made it later on. That's one gonna be application of tree itself in the graph theories and mainly gonna be used in computer network to find the maximum logistic way, not maximum, sorry, the minimum way to traveling around the whole network in the communication of LAN cables or the computer server to have the highest efficiency between one another. That one is more like the economic games kind of graph theories in maths. But I think this one is a little bit more advanced and can be skipped out right now when we need to fasten the process to getting the grading on times, and then it can be made later on as additional materials course. I'm gonna make a lot of additional material course. There are a lot of things that I promised to you guys, but right now I didn't have enough times to implement it for use. Even though that's not gonna make for you doesn't need to watch those videos that will come later on, and it's mostly going to be additional materials for people who still interest in it. And two things that I would like to make is the advanced implication of some data structure, and the other thing is the implementation in code for many of the concept I teach to you guys, but I didn't have times to show the code implementation either in C, in Python for you at all. So today the binary heap tree itself is something that very similar to binary search tree. So the heap data structure in general can be categorized into two main categories, either max heap or minimum heap. So it's binary heap tree, so we can say like, okay, generally speaking, it's also binary tree. If you have one single root, for each root in the subtree, you can have only two shards, either on the left and on the right. And for max heap itself, it need to have recursive properties for each subtrees, that all root, if the node itself represents itself as a root, then their shard have to be lower value than the root. So the root have to be maximum one. Okay, so right now you see like 35 here and 15 and 29 here. So 15 and 29 is lower than 35. So this subtree maintain the properties of max heap already. Okay, but the next step, we can look at each shard as a root node of this subtree, and it still need to contain the same property that this node have to be the highest value among all. So you can see like 15, if you want to make it to be max heap, then the shard node on the left and right have to be lower value than 15 itself. Okay, this one as well. If you look down here, then 20 and right here you can see like 32, which is out of bound. This one, if you have 32 here, then it means the whole tree is not max heap anymore, because they have the value that higher than the root node of itself, higher than the parent node of itself. You cannot have this kind of value. It have to be something else. For example, if I edit this value to be 2, is still correct, right? Because it's maintain the same properties, that the child node have to be lower value than the parent node, no matter what. Again, like from the name, if this one is max heap, then min heap, in general, it can be just the same logic that the parent node have to be lowest value. So by the name, if max heap, parent node is gonna be the one that have highest value amongst parent and child, then this one have to be minimum value among the parent and the child itself. So this one is fully construct min heap binary tree. Minimum binary heap tree. So or you can call min heap. This one, the child node on the left and right is higher value than 35. Right here, left and right have higher value than 150s, and this one also have higher value than 127. So why you need heap data structure in general if it's too close to binary search tree? So this one in the past, the first time that it's being implemented is implement for doing sorting algorithm. So you can see like by this kind of representation, if you want to find the minimum value, you just pick up the root, or maximum value, you just simply pick up the root. So this tree simply made for sorting value in the past, before the implementation of quicksort has been discovered. But right now, when we have quicksort, and quicksort is much faster in general in comparison to heap sort, then people don't use heap sort anymore. Then why we need to learn it? Because heap itself find a new way to survive in the modern computer science, in terms of how to implement the queue of the queue that called priority queues, which is used a lot in scheduler, any kind of scheduler. So what is priority queues and how to change the tree to be the queues itself? First of all, I would like to say about how to transform heap structure into the queues, representation of array. So simply speaking, if you make a notation of the root as 0 index of the array, and each level from left to right, you increase the value index by 1, like 0, 1, 2, 3, 4, 5, 6 here. Then it will become the series of value that can be called by simple equation right here, that for any single node, if you want to go to the parent node, you use their index -1 divided by 2. Okay, then you can go to parent. If you want to go to the child node on the left, you use its own index multiplied by 2 and +1. Or if you want to go to child node on the right, you multiply by 2 and +2. So we're gonna prove it. Like 1 multiplied by 2 is 2, +1 is 3, which is left, +2 is 4, which is right. If you want to go to the parent, you just -1 divided by 2, which is 0, right here. So it means like by the representation of index that you can simplify it into the series of equation, which is in the same time also a recursive function as well. Okay, right here I want to show you the example. Like if you have one more level here, then the index should be 7, 8. Still use the same equation, because 3 multiplied by 2 is 6, +1 is 7, which is the left one, +2 is 8, which is the right one here. Then you can change the whole heap tree like here, ignore those two, into the sequence of number, which is like 35, 15, 29, 13, 10, 22. Okay, and the index starts from 0 and so on. So from the array itself, array of queues, then you can simplify, not simplify, but then you can call it in the binary tree like structure by this sequence of index. And what does this mean for priority queues? For those specific type of queues, the value here is not just random value. It has to be used as a efficiency cost. For example, if this one is the CPU scheduler, in the CPU itself, you have a lot of tasks that you throw in your computers at the same time. If you use Windows, you press Control Alternate Delete and you open Task Manager, you're gonna see like more than 20, 30, 40 tasks running in the same time, even though you doesn't open anything in your PC. Then how CPU itself switching from one task toward another. It means every single task should come to CPU scheduler with some specific value that tell them, okay, how long does it take to run this task, or how much computational power to use for running this task in term, like for computational power, we use the units of flop. So if all the tasks came in the scheduler, then they try to represent it in terms of priority queues, that everyone came with the numbers, and being sorted in terms of heap kind of structure, that the child node have to be lower value than the parent or higher value than the parent. Then whenever the scheduler design for running the minimum one first or running the maximum one first, they just kick out the root and then find the new max or min value and represent it to the root of the heap. It's going to be much faster to represent the queue this way to work as a scheduler. That for example, if I want to kick out the value 35 here, I want to run this one, so I remove it out of the queues. Then among them, I just try to find new root and bring it back to be the index 0. Then the whole queue is gonna be able to maintain the same heap properties anyway. That's why it's pretty useful. Then come to the kind of question that we need to do is, whenever you get the array of the queues, is it already represent the heap structure or not? I think that's one going to be interesting to do as kind of assignment to do the practice of either making pseudocode or flowchart of how to algorithmically looking at each array of the queues and try to find or figure it out that is a max heap or a min heap or not. However, yeah, that's all for today. For the heap data structure, you can see that it's just almost the same concept with the binary search tree. But instead of making for sorting number from ascendant to descendant way, like binary search tree, this one made specifically to prioritize the value that came in sequence, and right now has been used a lot in when like you need to learn this data structure and memorize it, because whenever you learn the micro computers class or microcontroller class or OS operating system class, they're going to use a lot of heap data structure to work as a scheduler of CPU itself. Okay, that's all for today. And as I mentioned before, we're gonna provide another assignment for heap construction in Facebook group. And also, I still promise that I will make additional content for the class and upload in the YouTube channels, and you still be able to consult me and look at those material by yourself voluntarily. even after class, you still be able to consult me, even though we already announced the grade and the class already end. I would like to provide the whole thing that I want, the whole content that I want to provide to you guys, and promise to do, no matter what it take or how long it's gonna take. And sorry for overall delay of the class. I still want to make it in the good manner to you guys, in the way that you guys feel comfort enough for the whole class in general. Okay, that's all for today. Thank you for watching and see you again next time. Bye bye.